How to write cell notation? Okay, first of all, you need to know to identify which is anode, which is cathode. Okay, let's look at sample number 1 that uses active electrodes for cell notation. Okay, a galvanic cell is made up by immersing zinc metal. Okay, so we know it's zinc solid. Okay, in 1 molar of zinc solution and copper metal, so Cu solid, okay, in 1 molar of copper solution. The two half cells are connected by a salt bridge. Key electrons flow from zinc to copper. So meaning that now we know zinc is anode, then copper is cathode. Okay, so remember for writing cell notation, on your left, it must always be anode. So automatically, after the salt bridge, on the right, it will be cathode. Okay, so what are the electrode? Okay, usually I will tell students at the end of both, cell notation, it must be solid. It must be the electrode solid. Okay, so now we already know that zinc metal is anode. Okay, so we put zinc first. And then just now we also know that copper will be cathode. Okay, so we put copper. Okay, then of course, the in between the ions, if you want to find out the ions, then what you need is you need to write the half cell reaction so that you know what are the ions present. Another one is easily you know what are the ions present because in the question itself, it has already mentioned that 1 molar of zinc 2 positive, 1 molar of Cu 2 positive. So straight away, you can write in the cell notation. Okay, and remember, don't forget to label your salt bridge. Okay, another type of question. Okay, based on the overall cell reaction, okay, you are given this overall. Okay, so let's say the overall cell reaction, you must determine which one is anode, which one is cathode. Okay, let's say I use copper positive. So positive 1 becomes positive 2. So the oxidation number increase. So it is anode. So copper is at anode, then automatically cathode will be iron. Okay, but look carefully in our equation. There is no solid in our half equation. So what we do is means that it is not using active electrode. Okay, means that copper I will not be using copper metal. Iron I will also not be using iron metal. The best one I would suggest is to use platinum, which is inert electrode. Okay, and then I also want to highlight, remember, because all the ions, okay, are aqueous, so means you have two things here, two same phase here, so you have to write comma instead of the stroke. Okay, now we go to another one, the third one. Okay, so remember the inert electrode, usually we refer to platinum or carbon. Okay, now third one, electrode involving gases. Okay, a galvanic cell contains zinc anode. Okay, again, straight away it has tells us that it is zinc anode immersed in a 1 molar solution of ZnSO4 positive. Okay, if ZnSO4, sorry, not positive, ZnSO4 means there will be Zn2 plus and SO4 2 minus ion. So that's why we have Zn2 plus here. And a platinum cathode, okay, easy to understand. Platinum, Pt, platinum cathode. okay, that has a gaseous hydrogen, gaseous hydrogen bubbling over it at a pressure of 1 atm. The hydrogen ion concentration is given 1 molar. Okay, so this question has clearly stated which is anode, which is cathode. Okay, only one thing that I want to remind the students is sometimes we will write the half reaction. Okay, when you write the half reaction, maybe you will get a factor of 2. The coefficient is 2. But you do not include into the cell notation. Cell notation, you only include the electrode and the solution ions and the gaseous in their state only. And of course, remember the pressure is how much is given. You do not add in the coefficient. Okay, that is the common mistake which many students did. Okay, another one is, I will go back to the inner electrode. Okay, students also would like to ask, should I write Cu plus first or Cu2 plus first? Okay, now this one is up to you. Okay, because actually if you write Cu2 plus and Cu plus or Cu2 plus, the answer is acceptable. Okay, it will be the same. But I would prefer if you can show that at anode, or an anode is oxidation, so you show like positive 1 becomes positive 2. So that shows the increase of oxidation number, which shows that it is anode. Okay, same goes for cathode. Cathode is 3 positive, 2 positive, 2, which shows reduction. But of course, whatever you want to write is correct, because in a solution, okay, it is mixed up. It is not specifically static at one place. Okay, so that's all for cell